All right, now a few words about multiple regression. Multiple regression helps you to build an equation, just like I was talking about earlier with just a simple regression or bivariate regression. Multiple regression has more than one predictor variable for the dependent variable. Or another way to talk about these various variables is to call them independent variables. So you have a formula by which each variable gets its own slope, there's an intercept, and if you were to calculate it inputting the independent variables, you would arrive at some prediction for y, the dependent variable, and you would have some multiple r, which would be as range between 0 and 1. Obviously, as it gets closer to 1, these are doing a better job of predicting r and predicting y, and as it gets closer to 0, these are less associated with y. Multiple r, it cannot be negative, as opposed to in bivariate correlation, r ranges between -1 and +1. Multiple r is always either between 0 and 1. Very often, when you're running a multiple regression equation, you're going to use dummy variables. And that entails assigning nominal data a number. For example, socioeconomic status. You might take people who are high, middle, and low class and give them, actually it would have made much more sense if I had done 1, 2, 3 like that, but anyway, it doesn't matter. But in any case, you give them a number and you would include it there. You could also do that with gender. Male 0, female 1 could go in. That's what dummy variables are. It's a very common thing in social sciences research to use those. The other thing I want to say about multiple regression is that I'm sure that you've heard of stepwise multiple regression algorithm. It just means that you have a bunch of variables, and PASW or SPSS, whatever you're using, asks the question: if I put this x in, does it significantly increase my multiple r? If it does, that variable stays in. If it doesn't, that variable doesn't go in. And what happens is, if you have a significant relationship between your variables, then you could have a situation where when I put x1 in, it significantly increased multiple r, but when I put x2 in, it reduced the value of x1 because x1 and x2 are so closely related. Like, let's say that x2 was education or something, and the procedure might determine that actually you don't need x1 if you have x2. Because there's so much overlap here that it doesn't make sense to leave both of them in the equation. Stepwise algorithms are very typically used in multiple regression equations. So again, that's sort of just touching on multiple regression, but I encourage you to, as always, when I touch on a subject, just spend some time reviewing that in your textbook.